then we will switch over to complicated structure. Geometry. First of all, take one plane, xy plane. I will draw one circle. Hollow shaft I will draw. Hmm? I will draw one hollow shaft. This is units in mm. Huh? I will take units in mm. First, second. Give constraints. Diameter of this I will take 50 mm. Diameter of this I will take say 30 or 40 mm. Okay. Then extrude this. Extrude length we will take 100 mm. Instead of 100, 150 we will take. Okay, and generate. Okay, so this is a hollow shaft. Now go to model. Just give meshing. Now it is uniformly meshed. Our next is now here analysis settings. These are very important. No? This I will tell you. First of all, I will fix this shaft. I will fix this shaft in x and y direction. And z direction I will keep free. Displacement. So x direction and y direction fix. So 0 I will enter x 0, y 0. Okay. Then insert force, we will apply force. Okay, better than this we will fix this in all direction. X, Z, Y 0 0 all displacement fix, and we will apply force here. Force in negative y direction, E vector negative direction, y component suppose minus 100 Newton. Very small amount of force. Is it correct? Okay, it is correct. You can see here it is applied in downward direction. Okay. Then now analysis setting. Here we have to control now. If we keep on solving, it will not end. 24 hours, 48 hours, it will not end. So maximum number of cycle here 1 into 10 raised to 7. These are the maximum number of cycle. If we keep these cycles, it will take 24 hours. Are you getting? So I will take just 100 initially. Okay, and end time we will take very less, that is 0.001. Okay, we can take here 1 second, 2 second also, no problem. It depends on you. So you want response of this hollow beam within 0.001 second. You want this response. Now just give solve command. It will take only few minutes to solve. Now you will get vibrations at each point in this beam. This is very simple problem. In explicit dynamics, joint loads you cannot give. But in transient structure analysis, now we will see few problems. In transient structure analysis, joint load you can give. there will be two revolute joints. One circle means one shaft and one hollow shaft. Both are rotating. That you can do in transient structural analysis. Okay, now this solution is done. Now we will see suppose deformation total. Okay, it is total deformation, and you can see here. These are the two vibrations. Now, particularly if you want response at one point, you can take that response. First of all, what we will do, we will select a probe, and in that probe we want deformation. So you can select this point and you can solve this. Okay. So at that time displacement is 0. Now you can see this graph. This is a plane. Are you getting? And this is what displacement is getting increased with respect to time. Are you getting? This graph is plane. But if you increase number of cycles, this number of cycles 100 I have given. Instead of 100 I will give now 200. Now you will see different answers. Huh? Now cycles I have increased. Number of cycles I have increased. Now you see the change in answers. Little bit nature of graph will change. Very little bit. Okay. Now you can see little bit. Now you can see here three answers you are getting here. Tabular data. Are you getting? Three answers and maximum displacement. Now you see maximum displacement is 1.2 into 10 raised to minus 6. At what time? At 5.2 into 10 raised to minus 5 seconds. Are you getting? Means fraction of second. Now I will increase little bit iterations, or what we will do, 0 point we will keep 0.01, means time is increased. Now you will get response. Now it will take more time for getting answer. 0.01 means more time. So such answers you are going to get on FFT analyzer. There you can measure the vibration. Explicit dynamics is only used to know the vibrations. Displacement of each point in the model. Okay. Now total deformation you can see. Answer is different. 1.2, 401. Are you getting? Then you can see stress value. These are also changing with respect to time. 1 minus stress. Are you getting? These are also different. Now you can see the beam is not getting deformed. Force is applied. Why it is not showing? Who will tell me? Why force is applied in this direction but it is not getting deformed? Listen carefully. This is deformation in 0.01 second. When you apply the force in 0.01 second, beam is little bit deformed. Are you getting? If I give here 1 second, then it will show more deformation. After application of force, within 0.01 second, beam is little bit deformed. After application of force. Are you getting? After application of force, force apply केल्यानंतर if you see response within 2 seconds, you will see more displacement. Are you getting? Now I will increase the time. Now you see the displacement is 1.2 sorry, the displacement is 1.2 into 10 raised to minus 6 meter. Now we will increase time 0.0 instead of we will show right here 0.1, and maximum number of cycle 200 we have taken. Instead of this we will do here now 1000. ठीक है. It will take little bit more time. आता बघा किती वेळ लागेल. N number of projects you can do on explicit dynamics. ANSYS software is whole about explicit dynamics. If you are perfect in explicit dynamics now, rest of the analysis you can do easily. You need more practice on explicit dynamics. Okay. Now few results we have got. Total deformation. So this is graph of total deformation, and I will play animation. Now you can see the displacement is 7.6 into 10 raised to minus 6. It is more. Are you getting? Now it will see show more deformation as that of previous. Are you getting? Little bit displacement. You imagine 7.6 into 10 raised to minus 6 meter means how much displacement? You cannot visualize even. This is very little bit displacement. This much deformation you cannot visualize. Are you getting? Now we will increase time to 1 second, and we will give maximum number of cycle to 10,000. ठीक है. What you do, you start solving. Then I will tell you how to plot graph. Then I will tell you how to apply rotational velocity in this. You start solving this. It is just task of increasing time. You start solving. This is simple example. This is simple example. इथं बसा तुम्ही. We will see here how to plot the graphs. Now this is the graph of displacement. Are you getting? This is the graph of displacement. Now you see carefully. Suppose I want to know a displacement at a particular point and in y direction. Displacement at a particular point in y direction. So how to know this? So this procedure you are knowing, select mesh and single select and vertex. So I will select suppose this point and create named selection. Okay, suppose I will give here name ppk and ok. Okay, now insert deformation total, and in here geometry selection named selection, and here I will select this ppk. Okay, now I want total deformation. How to get this total deformation? Just evaluate all result. Now you will see the graph here. Are you getting? This is a graph of total deformation at this point. Okay. Then insert probe. So for a particular face I want acceleration value. Okay. So I will select here acceleration, and geometry selection we will select here face. Suppose this face I will select. Okay. And you want result in x direction, y direction or z direction. Are you getting? So here you have to select option. So you will get acceleration in x direction and solve. So this is acceleration in x direction. Acceleration in x direction. Suppose you want acceleration in y direction, select here y. Once again solve this. Now same acceleration, it is constant. Then suppose you want acceleration in z direction. It is also plane, no problem. And suppose you want total acceleration, evaluate all result. Same value you are going to get here. Now let us see about the stresses. Once again I will insert the probe stress. Now stress you want on this surface, external surface, and that stress you want in which direction? Suppose normal x direction, and evaluate all result. So this is the stress in x direction. Are you getting? Stress value in x direction. Similarly we will see a deformation, probe of deformation. So that deformation we will see in suppose z direction. Deformation in z direction. Evaluate all result. So this is deformation in z direction. Suppose you want deformation in x direction, evaluate all result. Deformation in x direction. Deformation in y direction. Deformation in y direction. So this is on surface. Next, suppose you want deformation on inner surface. Select inner surface only. Inner surface and insert probe, and select, suppose I will select stress stress distribution on inner surface. So that stress suppose you want in y direction. So select here result selection y, evaluate all result. So stress in y direction on inner surface. Are you getting? Stress on inner surface. This is a time with stress with respect to time table. You can export this table to Microsoft Excel. Each result you can export to Microsoft Excel. Suppose I will give name SS. Now these results will be exported to Excel. Are you getting? So likewise we can get the vibration in gears also. So we will do analysis of gear, explicit dynamic analysis of gear. Now you see this total deformation This is the total deformation of that particular point. You can see this particular point is getting animated. Only that point is getting animated. This point you can see here. Are you getting? This is animation of that node only. Only that node is getting vibrated. Are you getting? So each point you can in depth you can vibrate. Suppose you want number of nodes. Are you getting? This is only a vibration on single node. Suppose you want vibrations on group of nodes. How to do this? So for this, select mesh, select box. Okay. So you will select number of nodes. Many nodes we have selected. Are you getting? Many nodes we have selected and create once again name selection. So I will give here name suppose D triple D. Okay. Then suppose we want now stress on equivalent one versus stress on that name selection. So here name selection and here we will select DDD and evaluate all result. So you can see here stresses on particular part. Are you getting? And these stresses are changing with respect to time. You can see here time with respect to stress on the particular part you are observing. Suppose now you want to get the stresses along the circumference. So how to see this? I will select the nodes along the circumference. You see, select mesh, box select is there, and here is another type, lasso select. You can select in different way. Suppose lasso select I will select. Now here you have to create paint like this. Are you getting? It is just like a pencil. You just join this, that particular nodes are selected. Are you getting? And once again insert named selection. So I will give name triple F suppose. Then suppose you want to see a stress or deformation, I will select suppose now maximum principal stress, name selection and here triple F and evaluate all result. You can see the stresses on that region only. Are you getting? And the graph is generated here. Are you getting? So many results you can get. This is just what vibration analysis. Are you getting? You can see the deformation at any point. You can see the vibrations at any point. You can get the stress values. So whenever vibrations are there, stresses will be there. Listen carefully. Because vibration means what? Displacement. Displacement means what? Change in length. Change in length means strain. And finally it is a stress. Are you getting? So vibration analysis also gives stress values changing with respect to time. So this type of analysis is very important for any kind of vibration analysis. Are you getting? Now we will see another problem of explicit dynamics. Explicit dynamics of gear. Are you getting? Now you can generate a report. Here report preview. All results will be saved and you can get this report in Microsoft Word format. Yesterday I told this. Now report is getting generated. Report generation in progress. Okay. Now all this report is generated here with graphs and all. Now here you can see this option send to. Okay. Send to Microsoft Word. So all report is imported in Microsoft Word. Okay. Then you can save this report. Okay. Now here all report is saved. Now you can see the word tables, diagrams, graphs. So this is very important analysis. ठीक है.